Hello viewers, I hope you're having a good day today. Today, before us is expressing quadratic binomials as perfect squares. There's a topic, and to deal with this topic effectively, we'll be looking into 2 to 3 questions. And question number 1, we have find the number that must be added to x squared plus 14x to make the expression a perfect square. Hence, write it as a perfect square. Okay, so this is an expression, x squared plus 14x. And by the statement of this question, it says this expression is not a perfect square. So what is expected of us is to find the number that will make this expression a perfect square. And after we have found that number, we're expected to write the expression as what? A perfect square. So, in this single question, there are 2 tasks to be performed. First of all, find the number that will make it a perfect square. That's the first task. And the second task is to write the expression as a perfect square. So we'll proceed as follows. We'll start with the expression itself, x squared plus 14x. Now, if this is x squared plus 14x, what number must be added to x squared plus 14x? There must be a number to be added to it to make it a perfect square. So what is that number? How do we find that number? This is the term in x squared, and this is the term in x. So we are going to pick the term in x coefficient, the coefficient of the term in x. The coefficient of x there is 14. That's positive 14. So what do we do to this 14? We are going to take half of this 14. Half of 14, that is multiplying it by half. And that is the same thing as 14 divided by 2. Either you say 14 times 1 over 2, or you say 14 divided by 2, which is going to give us 7. So what do we do to this 7? We are going to square the 7. So we'll be having it as 7 squared, which actually is going to be equal to what? 49. So this 49 is the number that must be added to this expression to make it a perfect square. So x squared plus 14x plus 49 is now a perfect square. So 49 is the number that must be added to this expression to make it a perfect square. That is question number 1. That's the first task to be performed in the question. Now, the next statement says we should write the expression as a perfect square. Now, another thing you should take note of is this. We started with x squared plus 14x. So the original form of this expression has to be kept. Now, how do we achieve that? This is the original form of the question, the original question we are given. The expression we started with. Now, this 49 was not there, but it was added. Now, how do we deal with this 49? We are going to have to subtract 49. Since 49 was added, which was not there. So that we can have 49 minus 49 being 0. And of course, this expression plus 0 remain in its original form. Okay, now we want to write the expression as a perfect square as told to us in the question. How do we achieve that? We proceed as follows. We are going to have x squared plus 14x and then plus, now instead of writing it as 49, we are going to have to write it as 7 squared, which of course is the representative of 49 here. So 7 squared is the same thing as 49. So this is the expression as a perfect square. Now this minus 49 has to be there to deal with the 49 which was added. Okay, now we want to express that as a perfect square. This is x squared, we are going to write only x. And this is 7 squared plus 7 squared, so we are going to write only plus 7. And then we are going to bracket both square minus 49. So this is the expression as a perfect square. And this expression is still keeping its original form, because when we expand this bracket and eventually subtract 49, we are going to return back to this expression. So that is question number 1. That helps us to write a quadratic binomial as a perfect square. So we'll proceed to question number 2. By the time we solve question number 2, question number 3, we are going to have better understanding of this concept. Question 2. Question 2. Find the number that must be added to m squared minus 8m to make the expression a perfect square. Hence, write it as a perfect square. So we'll proceed like before, we're having m squared minus 8m. That is the expression. So we want to look for the number that will make this expression a perfect square. So to write it as a perfect square, we'll be writing it as m squared minus 8m plus. So this plus is waiting for the number that will be added to it to make the expression a perfect square. And like we did in question 1, we are going to take the coefficient of m. This time around, the coefficient of m is negative 8. So we'll be having negative 8, and we are going to halve it. That's by multiplying it by half. Half is 1 over 2, and it is the same thing as negative 8 divided by 2. And negative 8 divided by 2 is going to give us negative 4. So what do we do to negative 4? Of course, you guessed right. We are going to square it. We are going to be having negative 4 squared, and of course that's going to be equal to 16. So that says that it is 16 that must be added to this expression to make it a perfect square. So we are going to be having it as what? Plus 16. Also, not forgetting that the original expression was m squared minus 8m. Now we have added 16. That 16 has to be subtracted also, so that we'll be able to keep the original form of the expression, which is what is inside this bracket. Okay, so we have answered the first question. 16 is the number that must be added to make it a perfect square. Now the next question, which is the next task in the same question, says write it as a perfect square. So we'll be having it as m squared minus 8m and then plus. Now, instead of writing 16, we'll be writing negative 4 in bracket squared. So negative 4 squared is the representative of 16. And then since it was added, it has to be what? Subtracted also, to keep the original form of the expression. Okay, so we need to tidy things up now by summarizing as a perfect square. So we're having m squared here, we'll be writing as m. Here we're having negative 4, so we'll be having minus 4, and that's to be squared. So this is a perfect square in summary form, summarized form. So, and that's going to be what? Minus 16. It means that when we expand this bracket completely and we subtract 16 from the expansion, we'll be left with m squared minus what? 8m. So, but with what we have here, we've been able to write this expression as a perfect square. So that is question number 2. We'll proceed to question number 3. Question 3. Twisted a little, but still same as question 1 and 2. Okay, question 3 says, for what value of k will the expression p squared minus 12 over 5p plus k be a perfect square? What it's only saying is that find the value that must be added to, find the number that must be added to p squared minus 12 over 5p to make a perfect square. So we're only looking for the value of k. That's what the question says. So we'll proceed to the solution this time around, and we are having p squared minus 12 over 5p and then plus k. So we are looking for the value of k that will make this expression a perfect square. So how do we get the value of k? Like we did in question 1 and question 2, we're going to take the coefficient of p. In this case, the coefficient of p is negative 12 over 5. And we are going to halve it, that is by multiplying it by 1 over 2. And when you multiply this by 1 over 2, that's going to give us negative 12 over 10. When simplify and reduce to the lowest term, it's going to give us negative 6 over 5. So that negative 6 over 5, what do we do with it? We're going to have negative 6 over 5 being squared, which of course is going to give us 36 over 25. Someone may ask, why is it that, like in question 2 and now in question 3, when we say negative 6 over 5 being squared, the negative sign is no longer there. It is because this square is actually going to deal with what? The negative sign. Because negative 6 over 5 in brackets being squared means negative 6 over 5 multiplying negative 6 over 5. So first of all, we know that minus times minus is actually going to be plus. So 6 times 6 is going to be 36. And 5 times 5 is going to be what? 25. So because it has become a positive number, we don't usually put the plus sign. So this square would have dealt with the negative sign here, and that's how we're having it as positive 36 over 5. So the value of k that will make this expression to be a perfect square is 36 over 25. So we'll say the value of k that will make the expression a perfect square is 36 over 25. So that is the question. Now you will see that mostly when I try to solve this question, I solve them at the other side of the board, indicating probably your jotting notes or a sheet of paper, a rough book where you can solve that. Now, but what if it is expected of you to put it inside your notes as you're having it here? All you need to do is that k has to be negative 12 over 5 multiplied by half and then being squared. So when you do that, you are going to be having negative 6 over 5 to be squared. And of course, k is going to be equal to 36 over 25. And when you have gotten that, you can now conclude by writing this particular aspect of it. But because whenever you are solving, the teachers usually don't want to see this part of it, because of course they will not give you this type of question in theory as only this one. The only type that they can give in theory is the likes of question 1 and question number 2. This type usually comes out in objectives. That's the multiple choice question most of the time. So that is what we have. I believe with these few examples, question 1, 2, and 3, you would have understood the concept expressing quadratic binomials as perfect squares. Until another time when I come your way, enjoy this and stay tuned to my channel. Thank you.